take a minute to read the question here. We're talking about daylight hours in Anchorage, Alaska over a 365-day year. So that's already suggesting I bet my period is 365 days. And there it says 365 a year. The longest day is on June 21st, and the shortest day is on December 21st. And the longest day has 20 hours, and the shortest day has 8 hours. Which models our graph? Notice it says measuring from day 1, December 21st. So I'm going to make myself a little sketch of what we have. Start with the low of 4 hours. So let's say this is 4 hours right there. We're going to go up to a high of 20 hours. And then of course we would go back to, so this would be December 21. This would be June 21. And then we'd be back down to the shortest day the next year, December 21. Well, as I look at this graph, I can see the midline between is going to be halfway between 4 and 20. Well, one way to find that is to just find the average. 20 plus 4 divided by 2 is going to be 24 over 2, which is 12. So that's really our midline. Our amplitude will then be the difference between 20 and 12 is 8. So as I look at these, none of these can be right. But we'll erase this one and make it 8, and this one and make it 8, because those are the closest. Now the next thing we need to look at is the period. They told us our period is 365 days, so that would mean the period must be 2 pi over b. We're really searching for this b, because we know the period is 365. So to get b all by itself, we'll multiply each side by b and divide by 365. b will equal 2 pi divided by 365. And that shows up in all of them. That should be an X there. The normal cosine graph would start high, but since this one is the negative of it, then it's going to start low and climb up. So that's our right answer after we adjust the amplitude to 8 instead of 10, because the difference between 20 and 12 is an amplitude of 8.